to generate the final output, to generate a rainbow of colors, each with a unique buzzer sound. To summarize this step 10, we connect push-button switch, buzzer, RGB LED, resistors, and Arduino such that when the Arduino is powered and we press the push-button switch each time, the RGB LED goes on and off or flashes in rainbow colors: red, green, blue, yellow, magenta, cyan, and white for a specified duration of time, and switches off when the switch is pressed again. This action repeats itself whenever the switch is pressed. In this circuit, we use components like the Arduino Uno, push-button, buzzer, RGB LED, and resistors of values 10 kilo ohms and 330 ohms in 3 numbers. Let's build this circuit in Tinkercad and simulate it. Let's draw the components mentioned in the circuit diagram seen earlier. So we will draw the Arduino Uno, RGB LED, push button, and resistors of value 10 kilo ohms and 330 ohms. We will connect as follows. Terminal 1 of the resistor 10 kilo ohms to the 5 volt of the Arduino Uno. This is positive line, so we shall select the wire color red. Terminal 2 of the resistor 10 kilo ohms to the terminal 1A of the push button. Terminal 1B of the push button to the D2 of the Arduino Uno. Terminal 2A of the push button to the GND of the Arduino Uno. This is negative line, so we shall select the wire color black. D3 of the Arduino Uno to the positive of the buzzer. Negative of the buzzer to the terminal 2A of the push button. D4 of the Arduino Uno to the terminal 1 of the resistor 330 ohms 1. Terminal 2 of the resistor 330 ohms 1 to the red terminal of the RGB LED. D5 of the Arduino Uno to the terminal 1 of the resistor 330 ohms 2. Terminal 2 of the resistor 330 ohms 2 to the green terminal of the RGB LED. D6 of the Arduino Uno to the terminal 1 of the resistor 330 ohms 3. Terminal 2 of the resistor 330 ohms 3 to the green terminal of the RGB LED. Cathode of the RGB LED to the ground of the Arduino Uno. We have now completed the circuit. Let's go to the code. Watch Introduction to Arduino Programming video before you proceed. Click the Code button. You see the default code here in the form of visual block coding. Delete the existing default code. Let's start building the new code. Change view to block plus text. You can see both block and text forms. First, we write the description of the code using notation block. For this code, we require variables, input, output, control, and math blocks. We shall create 2 variables. Button state and counter. Select the Set Button State block. Select the Input block. Take Read Digital Pin and set the digital pin to 2. As we have connected the push button on D2. As we have seen in previous video, we follow the same steps, so that every time push button is pressed, counter value increments by 1. We will create a condition such that when the push button is pressed, the LED will flash each rainbow color with buzzer sound for a specified time duration, so that we follow the same steps as seen in previous video. Set digital pin to 3, as we have connected our buzzer on D3. Set digital pins to 4, 5 and 6, as we have connected red, green and blue terminals of RGB LED on D4, D5 and D6 respectively. We shall duplicate this loop for further code in ease, and just change appropriate digital pins. For each counter loop from 1 to 8, RGB LED will glow with each rainbow color and buzzer sounds. The following code of counter 9 will turn off the LED when the button is pressed for the 9th time. Here also we shall follow the same steps as seen in previous video. The code is written to create a loop, such that when the button is pressed again for the 10th time, the LED behaves in a similar fashion as above, as also seen in previous video. Set counter to 1 as done earlier. We have completed the code and are ready for simulation. You see the on green LED glows on Arduino Uno, but the RGB LED does not glow and buzzer does not sound. When you push the button for the first time, RGB LED does not glow and buzzer starts sounding. When you push the button for the second time, RGB LED flashes in red color and buzzer sounds. When you push the button for third time, RGB LED flashes in green color and buzzer sounds. When you push the button for the fourth time, RGB LED flashes in blue color and buzzer sounds. When you push the button for the fifth time, RGB LED flashes in yellow color and buzzer sounds. When you push the button for the sixth time, RGB LED flashes in magenta color and buzzer sounds. When you push the button for the seventh time, RGB LED flashes in cyan color and the buzzer sounds. When you push the button for the eighth time, RGB LED flashes in white color and buzzer sounds. When you push the button for the 9th time, RGB LED does not glow and buzzer does not sound. And these go on. This is how we generate a rainbow of colors, each with a unique buzzer sound with Arduino using visual block coding. This circuit and code has many applications. A few examples could be mood light, rainbow lighting, and so on. You can now build your own circuit and write the code. Download the image file and submit in the assignment. Circuit explanation. Step equals step 2, with varying sounds for each step, plus step 3 to step 9. Each time you press the push button switch, a rainbow of colors is generated with a unique buzzer sound in accordance to the sketch uploaded in the module. The program is written in such a way that when you press the push button switch, the input pin D2 changes the state to logic low, and the output pin D3 changes the state to logic high in closed path 2, thus activating the buzzer. The program is written in the following way. When the push button switch is pressed for the first time, step 2 plus step 3 is executed, and the output is a flashing red light with a unique buzzer sound. When the push button switch is pressed for the 2nd to 7th time, step 2 to step 9 with a unique buzzer sound is executed, and the output is a unique flashing color from green to blue to yellow to magenta to cyan to white light, along with a unique buzzer sound. Now it is your turn to build the circuit and simulate it in the Tinkercad platform as per the instructions given in the assignment that follows. Have fun! Cheers!